All right. Hi, guys. This set of notes is going to be about equations of motion. So this is a super important one to watch and watch all the way through. I know it's going to be a little bit long, and I apologize for that, but it's got lots of important stuff. So the question that guides our notes here is how can we algebraically model the motion of an accelerating object? So we have something that's speeding up, slowing down. You know, undergoing what we call in physics acceleration. And how could we represent that or model that with an equation? Okay, so the big idea here is that there's three main equations for acceleration. Each one has four of the five variables. So those variables would be delta x, which is your displacement, v naught, which is your initial velocity, v, which is your final velocity, a, which is your acceleration, and t, which is your time. The three equations that we have are shown in this little chart here. So the first equation is v equals v naught plus at. So this would be your final velocity is equal to your initial velocity plus your acceleration times by your time. Now, as we note, it does not have displacement in it. It doesn't have delta x. So if you were wanting to know how far something went or how far it is from where it started, this equation doesn't help you. But if you want to know maybe how fast something's going after a certain amount of time, this equation would be useful for that. The second equation says x is equal to x naught plus v naught t plus 1/2 at squared. So that would be if maybe you wanted to know how far something has gone after a certain amount of time. So this one would relate distance to time for an accelerating object. So it's got your displacement, it's got time, it does not have final velocity. So if you're looking for final velocity, this one's not very useful for you. The last one has v squared is equal to v naught squared plus 2a delta x. So that's if you want to know how fast something is going after a certain amount of distance. So the different thing is that this one does not have time. So if you're given time, or if you want to know like how fast something's going after a certain amount of time, this one's not useful for you. But it's got final velocity and it's got displacement on that. Do note that all of them have your right? They all have an initial velocity, v naught, and they all have acceleration. So that is true. So usually the trickiest part is to choose the acceleration that has the variable you are solving for and the other variables that you're given. Okay, so the one that you are solving for and the other ones that you're given. So here's kind of some problem solving tips that I'd like you to follow. So the first thing is to make a list of all the variables that you have. So as you read through the problem, make a list of all the problems that are given. Write them out, and it makes it way easier to figure out what equation you want. Always write out the blank equation before filling in the variables. I should see at the beginning of your problem, right, one of these three equations written out. Okay, just like this, it should look just like that. I don't want to see any other variable or any variables plugged in quite yet, or any numbers plugged in. Okay, then you fill in the variables for the ones that you know. Show all algebraic steps that you need. So this is the part where I don't care as much. So as soon as you filled in the numbers into one of your equations, then you can, if you're needs to show the math steps to figure it all out, then show all the math steps. If you are pretty snappy at math and good at it, then you can skip a bunch of them. That part I don't really care. And then at the end, I want you to have your answer, and your answer needs to have units on it meters per second, or meters per second squared. With that, let's practice a couple problems. So here's the first problem that we're looking at. A truck has an acceleration of 2.5 meters per second. That's a 2.5, sorry, as it speeds up. If it starts from rest and accelerates for a distance of 875 meters, how much time does it take to cover the distance? Okay, so kind of picture this. We got our truck. And I'm going to say it starts here that x naught is equal to 0. So it starts there at 0 and it ends over here. Okay. So So that's kind of a little picture for us. If we go through what we know, a truck has an acceleration of 2.5 meters per second squared. Okay, so let's note the units, meters per second squared. That's going to tell you that's acceleration. So I can write that. A is equal to 2.5 meters per second squared. Next, if it starts from rest, okay, so this is a little bit tricky because it doesn't actually have a number there, but that is giving us some information, right? Starting from rest tells me my initial velocity is 0 meters per second. Okay, you should make a list just like this. It accelerates for a distance of 875 meters. So we already kind of laid that out. That means our initial position will be 0 and our final position will be 875. So one thing to kind of note, right, we do have an x and a delta x. And so just in case, it is kind of worth noting that so delta x, right, is equal to, which is your displacement, how far you are from where you started. That's equal to your final position minus your initial position. Well, in almost most cases, you would set your initial position equal to 0. So if you do that, right, then delta x is equal to x minus 0. So then delta x is equal to x, meaning, right, as long as you start from 0, then where you are is equal to how far you've gone. So for example, like if you're on a football field and you start running from the 0 yard line, then how far you've ran is also equal to whatever yard line you're standing on. That's kind of what's staying there. And usually we can set it up however we want. So we would start measuring from where the truck started. So this could be looking for delta x or x, depending on how you want to do that. Lastly, we're looking for time. So go ahead and write the t with a question mark so that you remember that your equation needs to have t. So the next thing to do is head over to our equations here. We have v equals v naught plus at. So we needed to have a time. So these two have t in it. So it could be either one of those. It cannot be the third one because it does not have a time in it. So can't be that one. So that leaves us these two. This one has a final velocity and this one has a position, right? So we are given the position, we're given that it goes 875 and we do not have a final velocity. So that tells us that we're going to need the second equation here. First step, so we've done the first step of writing out all the variables. Next step is to write out the blank equation. So before I plug any numbers into it, I'm just going to write it out. Like so. Okay, just copy it down. Then I'm going to go ahead and plug in the information I figured out. So 875 is equal to 0 plus 0t, 1/2 my acceleration, 2.5 t squared. All right. Now I don't need, right, plus 0 is obviously 0, so I can take that out. And 0 times by t, this is actually a really common mistake. 0 times by t is not t, it is 0. 0 times by anything, whatever t is, you multiply it by 0, it's going to go away. So real common mistake, watch that. Don't go, oh, 0 times by t, that's t. Mm-mm. It's 0, it also goes away. So that leaves us with 875 is equal to 0.5 times by 2.5, which is 1.25 t squared. Right? So then we're going to go ahead and divide by 1.25. And that's going to give us 700 equals t squared. Again, we're solving for t, not t squared, so we square root both sides. And so that's going to give us that t is equal to 26.5 seconds. Okay, a couple things to note. So make sure, right, note that I have units here on my time measurement. I didn't put units when I was working on the numbers in here because I find that at least for me, it seems to get messy when I have like S's in there and they look like fives and things like that, right? I don't have a meters right here. You can put them there if you want. I generally don't put it well into the equations, but I do, I note that I did write them way over here and you should as well. So I should see units here and I should see units here. So, okay, the next one. A car accelerates at 7.55 meters per second squared. If it starts from rest and accelerates for 4.25 seconds, what speed does it reach? Okay, so following along with our step, right? The first step is to make a list of all the variables. So it accelerates at, and here are my units again, meters per second squared. Those are the units of acceleration. So it says accelerates at this rate. So 0.55 meters per second squared. Okay, use those units to help you figure out what information you're given. Okay, if it starts from rest, oh, here's another that rest, that tells us that V naught is equal to 0 and accelerates for 2.5 to 4.25 seconds. So that's going to be T, right? Seconds are measuring time. What speed does it reach? Oh, that's the final velocity. Again, write the V equals question mark so that you remember that that's what you're looking for. Okay. So as we look at the information here, we're solving for velocity. Equation needs to have final velocity. So this one has final velocity. This one has final velocity. This one, the middle one, does not have final velocity. So it is not going to be that one. So now we got to decide, is it one of these two? This one has time. This one has distance. So are we given a time or a distance? If we go back, we're given a time and not a distance. So that's going to be the first equation. Next step is to write out that equation. So then leave the v in there, right? Leave it as a v because that's what you're solving for. Equals 0 plus 7.55 times by 4.25. And that's going to give you, obviously the 0 goes away. Plus 0 is not relevant. And v is equal to 32.1 meters per second. Note, I have the units on there, even though I didn't have them up here. Cool. So the last one here. A car accelerates at 9 meters per second squared. Meters per second squared are the units of acceleration. So that's going to be my A. If the initial velocity was 35.5 meters per second, units meters per second, initial velocity, that tells me that V naught is equal to 35.5. And its final velocity is 107 meters per second. So 107 meters per second is a velocity, so it's the final one, so just V is equal to 107. What distance does it cover during the acceleration? Okay, I want to know what distance, so that's either delta x or x. That's what I'm looking for. So I'm looking for either one of those because I'll just set the initial, for the same reason that up here we set, delta x is equal to x. So those are the same thing because as long as we set our initial velocity or position equal to 0, then those two are the same. How far you have gone is equal to where you are as long as you start from 0. So we'll take a look at this, right? The information that we're given. We don't have time. We are looking for x. We look at our list here, only these two have x, right? So the first thing you do is you look at which ones have x, only those two. And then we have and then we have a final velocity. So it's going to be this one, right? We do not have a time, so it's not going to be the middle one. So you can kind of narrow it down first by what are you looking for? So remember, first step is to write out all the stuff you're given, or the equation, sorry. Write out the equation. Let's see here. So final velocity is 107 squared. Initial one is 35 squared plus 2 times by 9 delta x. Okay, so don't forget to actually square these. So we're going to go ahead and plug that in. So that's going to be 107 squared is 111,449. 35.5 squared is 1,260.25 plus 18 delta x. The delta x is one thing. It's one variable. They're not two different things. So just kind of treat it as though that's the variable. We're solving for that delta x. So the next step is to subtract that from both sides. So that is going to give you 10,188.8 equals 18 delta x divided by 18. Delta x is equal to 566 meters. All right, there you go. There's your 3 example problems using the 3 different kinematic equations. Again, things that should be useful is as you read the problem, write out this stuff, make underlines, use the units to help you figure it out. Then go back, look at what equations have what things. What are you given? What are you given? What do you need? And to help you eliminate, right? Or just even process of eliminations, which one isn't going to work for you because it doesn't have the variable you need. And that makes it easier because the hardest part is figuring out which of the 3 to use. And you can help yourself out by trying to eliminate one and get it down to the other 2, and then look at what you have and look at what you need to get it down to the very last one. So I hope this helps you. It is a tricky thing to learn. So we're going to be doing lots of practice. The more serious you take the practice, which you probably will if you've made it to this point in the video, the better you're going to do. So, all right. Thank you for watching.